There are many types of monitors on the market today. Now that you've selected the single gas or multi-gas monitor that you're going to be using, it's important to get to know the instrument and all the different features that it has. The first thing that you're going to want to know is what the buttons are for, and most importantly, that power button. Before you head out to the work site, it's important that your gas monitor has the power that it's going to be needed for the day. Whether it uses a charging station, such as this monitor, or it has an internal battery, such as a single gas monitor that goes for 2 years, being sure that you have enough power is important. There are 2 key tests that you want to perform on your gas monitor to be sure that it is functioning properly. The first one is called calibration. Calibration checks the accuracy of the sensors within your monitor. It uses a known amount of gas to check that gas against those sensors to see that they are reading correctly. In this unit, the test canisters are ammonia and the mixture for the other gases that are present, such as hydrogen sulfide, oxygen, and methane. The system will read those gas and send it across that sensor to be sure it is properly working. Calibration is going to vary based on the make and manufacturer. Most of them will be wanting to be calibrated on a monthly basis. So check in your owner's manual to see what is the calibration requirement for the monitor that you have. The second test that you're going to want to perform is called a bump test. The purpose of a bump test is to check the sensors and to be sure that they are working properly. It is not a test of accuracy. Bump tests should be done on a daily basis or after any alarming event. It uses just a whiff of those test known gases to run across the sensors and to be sure that they are all functioning properly. You will also need to know your gas monitor's displays along with the alarm settings for the monitors. As you look at the display, be sure that you know where each of those gases are located in your monitor. This helps that if it alarms, you can quickly see which of the gas is alarming at that time. It is important to know the different alarms on your monitor. Low alarm, high alarm, immediately dangerous to life and health, or IDLH, are all important settings that you need to be aware of. For example, hydrogen sulfide on a gas monitor is typically set at 10 parts per million for a low alarm and 20 parts per million for a high alarm, and immediately dangerous to life and health, or IDLH alarm, at 100 parts per million. The 10 parts per million gives you a 90% chance of getting out of the situation without an impact to your health. The high alarm has an 80%, and the immediately dangerous to life and health means you need to get out now. Knowing whether you have a visual alarm, a sound alarm, a vibration, or all of those types of alarms are important to understand in your monitor.